In this example, we review some concepts of probability that will be needed in this course. Using the police force example in your textbook, we'll review the concepts of joint probability and conditional probability. The formulas we will use in this example are included in the first sheet of this file. I would like you to pause the video and read the problem in the text box before you go on. Okay, are you ready? As you have read, there is a talk of gender discrimination here because very few female officers were promoted in the last 2 years. Well, overall, 324 officers have been promoted, and out of that, only 36 were female. Of course, the administration would argue that, well, that's because there were such few female police officers to begin with. Well, what do you think? Well, we'll use the concepts of conditional probabilities to figure out if the numbers support the discrimination case. In the process, we'll also review the concepts of joint probability and marginal probability. First, we'll summarize the data in a contingency table. The rows of the table will correspond to the gender, okay, right here, and the columns will correspond to the promotion status. We first fill in the table with the numbers we are given. So let's take a look here. Here are the numbers. Total number of officers is 1,200, and then 960 men and 240 women. Okay, so overall total is 1,200. Okay, and 960 men and 240 women. Okay, and 324 officers have been promoted, and 36 were female. Going back, 324 were promoted, that's over here, and 36 were women, so that would be women who have been promoted, and that would be the count in that cell. Now it's easy to fill in the rest of the cells using the numbers that were given. For instance, here we have 324 who were promoted, 36 were women, so the rest must be men. And so we could just subtract 36 from 324, 324 minus 36, giving us 288. Now here we could take the difference between 960 and 288 to get the men who are not promoted. So 960 minus 288, giving us 672. And here we could say 240 minus 36 women. And 204 women were not promoted. And we could say, well, there are 1,200 total, and the 324 were promoted, so the difference must be the count of people who were not promoted. Say 1,200 minus 324, giving us 876. Or we could have just added 672 and 204 to get the same value. Next, we answer some simpler questions before we decide on the discrimination case. Let's take a look at the first question. It says, what percentage of the officers were promoted? Or equivalently, if a random officer is chosen out of this police force, what is the probability he or she was promoted? So here we're looking for the percentage of officers who were promoted, or probability of randomly chosen officers promoted. So we would write it as P of B, because B stands here for promotion. And how do we get that? As you might remember, you just take the count of the people who are promoted and then divide by the total number of police officers. So let's write it here. Number of officers who are promoted, and then divided by the total number of officers. So that would be number of people who are promoted, that would be 324, and then divide that by the overall total, 1,200. 324 right by 1,200, and that gives us 0.27 or 27%. Now let's take a look at the second question. Let's scroll down. What percent of the officers were not promoted? Well, as you might remember, this is just a complement of promoted, so we could write it this way: probability of B with a little c to stand for complement, and that would be you could just subtract the probability of B from 1 to get the probability of the complement. So we could say 1 minus 0.27 or 73%. Now let's take a look at the next question. If an officer is chosen at random, what is the probability this officer is a man who has been promoted? So here you have two things going on. The officer is a man, also he has been promoted. So there are two conditions here, and we want to know the probability the officer chosen meets these two conditions. So what we're trying to get is a joint probability. The officer chosen is a man, and also he has been promoted. So probability of M and B. Now this N, of course, means the intersection, M intersection B. It's just that and is easier to type when you type it. So we're going to just use and instead of this little symbol. And here again, we would count how many people satisfy both of the conditions, and then divide that number by the total number of people. So here we have to say number of police officers who are male and also have been promoted, and then divide that by the total number of officers. Okay, so let's get the data up here. Men and have been promoted, so that's here. 288 people meet both conditions, and we divide that by 1200. So 288 divided by 1200, and that gives us 0.24. So 24% or 0.24 for the answer. Now, question number 4. Out of the entire police force, what is the percentage of women who have been promoted? So this is again, similar kind of probability here. We want the probability that out of the entire police force, what is the percentage of women who have been promoted? So how many people fall into this category, women who have been promoted? So we could write women and also have been promoted. Okay, so we count the number of women who have been promoted and divide by 1200. So let's take that data. There are women who have been promoted, so that's 36. Put that in the numerator here of our fraction. And that is just a 0.03 or 3%. Or 3%. So only 3% of the entire police force consists of women who have been promoted. Now we'll go on to the next sheet called Police 2, and let's go to question 5. Here we're going to construct a probability table that where all the relevant probabilities are organized. So it looks like this. And to get these probabilities, all you have to do is take each value in the contingencies table and divide it by 1200. So what we'll do is I'm going to copy this down next to the contingency table and then fill in the corresponding values. Okay, so we're here. So we want the probability of M and B, which we already got before, and we had to do what? 288, and we have to divide by 1200. So it's 288 divided by 1200, and that's 0.24. And if I want the probability of women and B, W and B, is just 36 divided by 1200. Okay, and if I want the probability of promotion among everybody, I would say 324 divided by 1200. Okay, and let's speed this up. I'm going to just point to the cell 672 divided by 1200. Okay, so I'm going to use this formula. I'm just going to copy this formula by dragging. Before I do that, some of you might remember the absolute references. In order to make sure this part E13 doesn't change in the formula, I'm going to hit the shortcut key F4 to give me the dollar signs, which indicate the absolute reference. Okay. Now I'm going to copy this, let's see, down, okay, and just to so that I don't ruin my formatting, I'm going to go over here and say fill without formatting. Okay, and then I'm going to also copy these across, and again fix the formatting, fill without formatting. So now I have the complete probability table. Okay, now let's go on to question 6. Question 6. So here we're actually going to answer the original question. Now, is there a discrimination? So we're going to compare the promotion rate among male officers versus the promotion rate among women. That is, percent of male officers who were promoted versus the percent of female officers who were promoted. So if the male percentage is much higher than the female percentage, then we know there might be a discrimination. And this involves actually comparing two conditional probabilities. Now, what is a conditional probability? Well, let's talk about that. The conditional probability of A given B is right here, is a probability that A occurs given that B has occurred. So something has occurred. This B has occurred. Now we want to know the probability that A is going to occur. So let's talk about an example. Let's suppose I put all of 200 officers' names in a box and pull one out at random. And I want the probability this person, randomly chosen person, has been promoted. Now, suppose the name I happen to pull out is George. Does the name give any information about this person? Oh, yeah, sure. I would think, well, George is a man, definitely a man's name. So now I know this person is a man. Now I would know the probability this man has been promoted. And that probability is a conditional probability. We would write it like this. We would say probability promoted given male officer. Okay, what does this say? So this says probability that someone is promoted given, and this part is given. This vertical bar here denotes given. And what is given? Right here, male police officer. So given that we have male police officer, we want to know the probability this male police officer was promoted. Okay, so that's a conditional probability. That you have a given condition, we want to know probability of something else that hasn't happened, that is unknown. Okay, now that's different from probability of B, just plain old probability of promotion, because here you're not given anything, any information, whereas here you're given that you have a male officer. For instance, suppose that when we pull out our name at random, instead of George, the name happens to be Pat. Well, now the name Pat doesn't tell us anything about the person, because we don't know whether this person is male or female. Could be Patricia, could be Patrick, we don't know. You might recall the person Pat. There was a skit, kind of ongoing sketch of this androgynous character in the old Saturday Night Live episodes, and the way the person looked and sounded, we just couldn't tell what this person was, man or a woman. Now, these sketches were popular enough to actually spawn a film called It's Pat, but the film itself got a 0% rating on the Rotten Tomatoes. Okay, anyway, knowing a person's name is Pat doesn't give us any additional information, so the probability this Pat was promoted would just be probability of promotion. The promotion rate among men is a percent of male officers who are promoted, and this is a conditional probability. So this is what we want. Percent of male officers who were promoted is probability of promotion given a male officer. So P of B given M. And there is a formula for getting a conditional probability, but first let's just use the counts. So we could just actually say, well, we could ask, well, how many men were there? 960 men. And out of that, how many were promoted? Well, 288 of them. So we could just divide one by the other. So 288 by 960 men who were promoted here, divided by the total number of men, and that is 0.3 or 30%. So 30% of the men were promoted. Okay, but there's a formula for this. So P of B given M. Now let's take a look at the conditional probability formula. That's on the formula sheet right here. So this is what it says. P of A given B is equal to P of A and B or P of B. That is, you take the joint probability A and B on the top, and in the bottom you have P of the given condition, this part on the right side. Okay, so let's write it down over here, over here. Okay, and that is, and again I have to activate the pen. So that is, here we could say P of joint probability B and M, and then divide that by P of, the one on the right side, a given condition goes in the denominator, and that is, and P of B and M, that's over here, 0.24, and P of M is 0.8, so divide one by the other, 0.24 by 0.8, and that also gives us, 30%. And that makes sense because how did we get 0.24 and 0.8 in the first place? I got these numbers and then divided them by 1200. So it was like this. 0.24 was 288 divided by 1200. And 0.8 was 960 and divided by the same number, 1200. So if you were to simplify this, I would cancel out 1200, and then I'm left with 288 over 960. So the lesson is, I could just use the corresponding counts instead of using the probabilities, and it'll just come to the same result. Okay. Now, let's find the promotion rate among women. Okay, so let's come down a little here. Okay, so V1, promoted probability among women. So given a woman, what is the probability of promotion? So we're going to write promoted and women on the top, and this part, given part, women, will come in the bottom, and B and W, and let's say we were using the count. It would be women promoted, that's 36, and then in the bottom we're going to have probability of women, or the count of women, as 240. So we divide 36 by 240. So it's 36 by 240, and that gives us 0.15. 0.15. Okay. So what do we have here? Is there a discrimination going on? Well, I think there is. As the promotion rate among men is, 30%. Among women, it's only 15%. So if you're a man, then your chance of promotion is twice as likely as a woman. So it seems that the female officers have a good case for discrimination, at least according to these data. Now let's talk about independence. When we say events A and B are independent, we're saying that the probability of event A is not changed by the occurrence of event B, or vice versa. So it's a mutual thing. A and B are independent from each other. And here are the conditions you could check to see whether two events are independent. What this is saying is, for instance, probability of A given B is the same as probability of A. So whether B has occurred, or if you or not, or if you don't know whether B has occurred, probability of A stays the same. And here, same kind of thing. Probability of B remains the same whether A has occurred or not, whether you know A has occurred or whether you don't know. Now, you can use either condition to check for independence. Okay. Now, are the events M and B independent? Being a male, being promoted, are those two events independent? Well, we already did some analysis and it's pretty clear the events are not independent, but we're going to check using these formulas. Okay. Now, let's try maybe this one. Probability of promotion given M. Okay, so because we're checking M and B, B given M, is this the same as probability of B? That is promotion probability given that M, given you have male officer, is this the same as probability of promotion? Okay, now this one we know is, let's go up, is 0.3 and 0.3, and we know that the probability of promotion was over here, 0.27 is 0.27, so they are definitely not equal to each other. So we would conclude that M and B are not independent. Now that's enough to show that the two events are not independent. But just as a demonstration, I will also check the other, check it the other way. So M given B, is this the same as probability, of M? Okay, so I'm just trying it the other way as well. Probability of M given B, that is going to be probability of the joint M and B, and divided by probability of this one, B. Okay, M and B, so that is over here, 0.24, and the probability of B is 0.27, so that is 0.24 over 0.27, and that is 0.889. And here, probability of M was 8, as you might recall, over here. And these two are definitely not equal to each other, so we would reach the same conclusion. And just to reiterate, when you're solving problems, you don't need to check both conditions, and you just have to check one. And if one condition is equality, then we know the other one will be met with equality, or one is not equal, the other will not be equal. So you just have to check one.